Good morning, guys. So today what we're going to do is we're going to start by going over the three problems from yesterday. I'm going to do two word problems and give a definition, and then I'm going to give you guys the assignment. Now, technically you could be good to go, so if you want to skip around, either even just skip the video if you're like, I really understand this, I can do this with word problems, you can go ahead and try. And if you know that you got these right because you got the comment already from me, and you want to just skip to the second two problems, that's also fine. So take the learning that you need. Don't force yourself to sit there if you don't need it, okay? So let's look through these three problems then. So the first thing I'm going to write out is my guide, which is the formulas here. SOHCAHTOA. Remember, that's our shortcut. And there's one thing that you really got to watch out, and that is that you keep the angle with the sine, and that these parts are what it equals. So let's go through the first problem. So I have the angle 60, and that's the one I'm going to work with. The other two sides that I have are the hypotenuse, 17, because it's opposite of the right angle, and I have x, that's the side I want, which is the opposite of the angle that's given me, so I'm going to label it as O. So since I have O and H, it means I'm working with sine, and I can write out my full function. The sine of theta is always equal to O over H, right? The first letter that comes first is on top of the fraction. Now I can fill this in. The sine of 60 is equal to my x over 17. So in this case, to get x by itself, I have to undo the division and multiply both sides by 17. So the sine of 60 times 17 will give me my answer, and that is 14.7224. So go ahead and write that down. If you got that one right, nicely done. For our second problem, again, using SOHCAHTOA. In fact, I know I'm probably going to use SOHCAHTOA because I see I have a right angle, one angle here, and then two sides. Anytime you see that, probably using SOHCAHTOA. So if I'm using this, let's start by labeling. I have a hypotenuse at x, it's opposite the right angle, and I have an adjacent side. It's connected to my angle and not the hypotenuse. Since I have a and h, I'm working with ka, or cosine. So the cosine of my angle theta is equal to a over h. Now this is where a couple of you guys had some problems. When you fill this in, we know that we have the cosine of 51, but what happened here is a couple of you guys switched the a and the h. 10 here is a, and h is x. So currently we don't know what the answer is. In fact, this is going to take two steps to solve. First, you have to multiply both sides by x, because as long as there is a variable in the denominator, you can't actually solve the equation in one step for almost all equations. So multiply both sides by x. That's going to give you x times the cosine of 51 is equal to 10. Then you can divide both sides by the cosine of 51. Now I know that this looks like I'm doing something massive here, but the cosine of 51 is just a number, and if it's throwing you off, figure out what it is and use it as a decimal first so that you're not having to worry about cosine, but treat it like a single variable. Like I could replace this whole thing with t and that'd be fine. So I'm dividing both sides by the cosine of 51, and I get x is equal to 10 over the cosine of 51. So take your calculator, divide 10 by the cosine of 51, and you're going to get 15.89. Now again, you might notice a shortcut here. You could just take the x and the 51 and swap where they are. That's actually a shortcut with the means extremes property, but you don't have to. Last problem here, we have an angle, a right angle, and two sides, so I'm using SOHCAHTOA. Here, you might be able to guess already that we're going to use tangent because we haven't used it yet, but I don't have the hypotenuse. What I do have is the opposite side from my angle. I have the adjacent side. It's not the hypotenuse, right, but it's connected to my angle. and that means that I'm using tangent. So tangent, or TOA, is going to be the tangent of theta is equal to O over A. Here, that means that I have the tangent of 51 is equal to O, or X, over A, 12. Multiply both sides by 12. That will give you the X on its own because it's undoing that division. And so 12 times the tangent of 51 is equal to 14.8187. Or, sorry, this should be 53. So let me do that once more. The tangent of 53 times that 12 is equal to 15.925. Woo, nearly made a mistake there. All right, so now that we have those all set, let's take a pause here. I'll adjust things and we'll move on to our word problems. Whenever you're trying to solve a word problem, hello to those, by the way, who just joined us now. Whenever you're trying to solve a word problem, the first thing that you should do is skim the problem and see if you can set up pictures or formulas. So I know that I have a flagpole that casts a 22-foot shadow when the shadow makes an angle of 39 degrees with the ground. What is the pole's height? So this is kind of similar to the cactus problem that we could have had earlier. Let's start by just drawing ourselves an example of this. So I have myself a little flag and the ground. I know that this flagpole casts a shadow of 22 feet long. Now, when we measure a shadow, we're not measuring this line here, okay? What we're measuring is the line along the ground. And the flagpole, unless it's got some serious issues, should be at 90 degrees to the ground. So I'm going to just label that in here as well. I mean, maybe you're really bad at setting up flagpoles, but it should be pretty stinking close to 90 degrees. So the shadow makes an angle of 39 degrees with the ground. So here we should have a measure of 39. And we want to know what the pole's height is. Maybe someone climbed it and it's just like, look how tall I climbed, or how far I climbed. So let's actually solve this then. Well, as soon as I see a right triangle that has an angle and two sides, whether we know them both or not, that means I'm probably going to be dealing with SOHCAHTOA. So I write that out immediately. And then the next thing that I do is I find my indicated angle. And the indicated angle in this case is this angle of 39. And I like to physically mark it so I can really see what I'm working with. So 39 has a side opposite of it that is x, and it has a side adjacent, right? It's not the hypotenuse, but it's connected, of 22. Since I have O and A, it means I'm working with tangent. So tangent of my angle will equal O over A. And write that out very carefully here. Now substitute in your values, and unlike my last problem, please make sure that you write the angle in right. So I got 39 degrees here is equal to x, my O, over 22, my A. And in order to solve for x, just multiply both sides by 22. So we have 22 times the tangent of 39, and that will give you an answer of 17.815. And we are dealing with feet here, and since this is in proportions, it's going to automatically give you the same units as what you started with, okay? So this is 17.81 feet tall. For our last problem, we're looking at Colorado. The Zephyr Express chairlift in Winter Park, Colorado has a vertical rise of about 490 meters. Suppose the lift travels at an average 16.7 angle of elevation, and we want to know how many meters long is the ride. First up is our picture. So let's go ahead and draw ourselves a chairlift. I'm not even going to try to do details here. You guys know I'm not a good drawer. So it has a vertical rise of 490 meters. Now what this is just saying is it goes up vertically. right? Break it down based on the terms that you have. So if you're looking at vertical elevation or vertical height or vertical rise, it's just saying this actual height of it. So this is 490 if you're going based on the flat ground. And we know that it has an average 16.7 degree angle of elevation. Now this is a pretty key term. In fact, I'm going to give you another one. But angle of elevation and angle of depression are two things that we talk about a lot when we're talking about real buildings. And here's what they're essentially talking about. Let's say you have two parallel lines running, like the top and bottom of a building, or like the horizontal heights, two various horizontal heights. The angle of elevation is this one. It's how much you're elevating from the ground. But with this, there's also a second height that we call, or a second angle that we call the angle of depression. Not because it's depressing, which maybe it is to you, but because it's the depression or the dip from horizontal. Now, it just so happens that the angle of depression equals the angle of elevation. So if this is A and this, or let's just call this one D for depression, and this one's E for elevation, those two are going to be equal to each other. D is equal to E. And you can see that it's actually one of our previous theorems. Bonus if you can tell me which one it is on your homework. But those two will then end up always being equal. Not super important for this problem that these two are equal because we aren't dealing with an angle of depression, but sometimes it's going to give you the angle of depression, like this angle right here, and what you really want is this angle of elevation. Just swap them out. Just make sure that you put it in the right spot, okay? Because it won't work. Like, this angle of depression is not the same as the angle from here to here, right? Those are actually complementary. They'd add up to they'd add up to 90 degrees. So just watch out if you're doing it that you're putting it in the correct spot. But in this case, we don't need that, okay? All we need to know is that the angle of elevation is talking about the height from the ground up. So we're talking about this one here as 16.7. Now, I always try to find right angles, and this should be right angles from its highest height to the flat ground, even though there's a mountain in the way. So what we want to know is what is the length of the ride. And the length of the ride is talking about the actual ride. So that's the hypotenuse, not this horizontal length, because you're going to go further than that. So now that I have all those three things, I can look at what formulas I'm going to use. And again, I see I have a 90-degree angle. I see I have another angle and two sides. That means SOHCAHTOA is my best bet. And here, I can label my angle as theta and my two sides as opposite and hypotenuse. So that means I'm working with sine. And the sine of 16.7, or sine of theta, will be equal to my opposite, which is 490, over my hypotenuse, or x. Again, I'm going to use a shortcut here rather than multiplying both sides by x, but because x is trapped in the denominator, I need to get rid of it first. So you can do this the long way, or you can just remember this shortcut where you can swap the places and get x is equal to 490 over the sine of 16.7. And that would be your final answer, actually typing it out, of course, because we don't want to leave an answer that's quite that much of a mess. And that gives you a length of 1,705.175. And now this length is quite reasonable. I mean, you're not going very high, but see how small this angle is? This thing's going to stretch pretty stinking far. And that's why I also never trust your picture. You're just sketching it on a random shape, basically, so that you can figure out the patterns, not because this length would look like this compared to the 490. Well, that is it for my instructions for today, aside from your homework. And your homework can be found here, page 81, 1, 3 through 6, 15, and 16. I hope you guys have an excellent day. Goodbye.